Good. Let's get started. Good afternoon. I'm Philipp. I'm from Vienna. Those who haven't seen me yesterday, I'm always starting my presentation the same way. I'm Philipp. I'm from Vienna, city of fatty foods, classical architecture, and beautiful women. Um, yeah, but we are all huge fans of her, so it's kind of a token of appreciation. I'm still with Elastic. I'm part of the infrastructure team, and I'm always saying I'm taking my infrastructure work, and this is actually a pipe, like a Unix pipe, and that I pipe into developer advocacy. So today I'll talk about our products again. And I'm doing meetups, one about databases in general and one about papers, though we don't want to go too much into the theoretical side today. So, who uses Elasticsearch already? Okay, that is quite a lot. Let's see. Let's see how much you know. Let's see if you disagree somewhere, if you don't know, and I'm looking for active feedback afterwards because this is the first time I'm doing this kind of talk or this specific topic, so your feedback is much appreciated. Okay, so as everybody is probably aware, deep down in the bowels of Elasticsearch there is Apache Lucene, and that is kind of doing the hard full-text search work. We have talked about that yesterday. And Lucene was started by duck cutting in, I think, 1999, so that is kind of quite old. And I think he's also started the Hadoop project, so duck cutting is a guy who did lots of cool stuff and started lots of stuff. And then there is Elasticsearch, started by Shai Bannon in 2010, because he was not satisfied with what was there already, because he was looking for like a lightweight solution which he could easily distribute for full text search. And actually Elasticsearch is the third implementation of him. So he had two other implementations. Those were called Compass 1 and Compass 2. And then Elasticsearch is kind of Compass 3, but he renamed it, and obviously 3 is the lucky number, so this really took hold, and now it's widely used. The other ones didn't really get the community, and some people used them. At my previous job, my colleagues used Compass 2, and then when I started there, they said, hey, there's this new thing, Elasticsearch, check it out, and I think it was 2010, so it was the first year right after it came out, I started playing around with it. And that is Shai. That is not a good picture, but this is still his Twitter handle and the picture on GitHub he has. And at my previous job, we would always call him the search beast because he looks so mean and he doesn't have hair. And back in 2010-11, there was no company, it was mainly him, and I always imagined him sitting in his bedroom and coding furiously, and he would release so much code every day and comment on all the issues and do the documentation, and he just did everything by himself. And that's why we always called him the search beast. But he can also smile. He's a nice guy. I don't want to give the wrong impression. Otherwise, not that somebody tweets out that I said, like, our CTO is a mean guy and he never smiles. No, he can smile and he's nice. Okay, so let's get started. We have a JSON document. I call it Exhibit A. Current version is 2.4.1, but I'm generally leaning more towards 5.0, which will come out really soon. So this is a generic JSON document. To insert it, we can either use curl. I guess nobody is surprised here. Yeah, I run my curl command. I add the I option so I can actually see the headers afterwards, and I see, okay, 201, I have created my document, and yeah, it got an ID, and the version is 1, and yeah, I choose the index database and the type NoSQL, and that it all is stored in the background. Or I can do the same in Sense or Console by now, which is slightly prettier and gives you pretty much the same output. So all we're basically doing is we have some kind of client, for example, running curl or sense, running a post against Elasticsearch and getting a 201 created back. And that was surprisingly easy, right? And setting up everything was surprisingly easy. And that was kind of the appeal of Elasticsearch right from the start, that it was so easy to get started. But what is actually going on under the hood? Like, all of this is pretty simple. And now here, this is more of a black box so far. And we'll try to dive into that and see that it's not so much of a black box anymore, but see what is actually happening in the background. So, assume you start a single node. This would be the easiest solution. You just download the zip version and run that on every operating system. We, of course, have proper installers for Ubuntu and all the other operating systems as well. And then you end up with a single node, and that will be a master node. And it will just run. Or you create a cluster. Previously, those of you who have used Elasticsearch like a few years ago, back then when you started Elasticsearch, it would actually broadcast and search for other nodes actively. And it would automatically cluster every single Elasticsearch instance you would find on the subnet, which was kind of nice, but it's also super confusing because when I did trainings and stuff, people would just start their one node to try stuff, and then it would cluster all around. And it would be a single cluster. And it's especially fun if somebody's running unit tests and starts up an Elasticsearch node, maybe embedded, and then it suddenly clusters with somebody else running unit tests. And then, of course, you have a collision and nothing works anymore. So we have changed that. Elasticsearch is no longer broadcasting. You actually need to specify which nodes to join. So you don't get into these kinds of problems. And it's kind of, at first it was very nice to get started, but incrementally we kind of need to lock down certain things to improve and avoid issues. So once you've started, for example, 3 nodes, it could look something like that, and it will run happily, even though you don't really know what is going on or what node types you have. So let's see what node types we have. First off, are the so-called master eligible nodes. When you start a node, it will be master eligible by default, and it does stuff like the cluster state. So the cluster state, or the global cluster state, will be stuff like which indexes exist, which mappings are there, which nodes exist, when you add a node, when you remove a node, and you don't actually need to talk to the master when you actually interact with a single document, neither for searching nor querying, but it's just like, this is the global cluster state that is available in your network, and there will only be one single master elected out of the eligible master nodes. In combination with that are the data nodes. Those are the nodes actually storing your data. So this will be on by default as well. So once you start up a node, it will by default be both master eligible and the data node. So the data node is actually the thing storing your data, and when you query data, this will give you back your data as well. Then you can actually use client nodes. Client nodes do not keep the master or the state of the cluster, and they do not keep actual data. The client nodes are just your client can connect, or your application can connect to them, and then that node will go out to all the required Elasticsearch data nodes and fetch the actual data and coordinate that. Is anybody using dedicated client nodes? Nobody. Okay. No, this is just kind of feedback we always want to see, like who is using what feature. Why would you want to use client nodes? Okay. I'm not impressed. No, I'm kidding. Actually, I assume they behave the same, but I'm not a Solr expert. I don't know. But okay. Assume the thing is, why would you use a client node in Elasticsearch? You have your data nodes, and they're normally good at just like serving as much data out of their memory as they can. And sometimes you, for example, want to run aggregates. And aggregates potentially take up a lot of memory. So you do not want to run that on your normal data nodes, because to get that big aggregation, they would need to throw everything else or lots of stuff out of memory and just do the aggregate in memory. And then they would need to go back to disk and just fetch the documents they have back to memory. But what you actually want is to have the data nodes just everything cached, or as much cached as possible from the file system, so you can serve every request very easily. Whereas the client nodes, they don't have actually any actual data cache. They just do stuff like going to the data nodes, aggregating little bits and pieces, and then putting that together as a big aggregate. So especially if you run heavy aggregates, client nodes are a good solution for you. And they serve as a kind of a smart load balancer. You could run the load balancer in front of Elasticsearch as well, but you don't really need to, because that is what client nodes can do for you. And if you start a node and explicitly disable it to be not master eligible and not a data node, it will end up as a client node. Next up, tribe nodes. Anybody using tribe nodes? Yeah. Who has heard of tribe nodes? Nobody. Good. I can tell you something new. Okay. Tribe nodes is, as you might be aware, Elasticsearch at the moment, all the nodes of one cluster need to be in a single data center. And tribe nodes are one common solution either to connect to multiple clusters in one location or to connect to clusters in different regions. So for example, we have very big customers. They have different data centers in different regions, but they want to be able to query all of that data together. So they run one cluster or multiple clusters in each region, and then they have a so-called tribe node, and that tribe node is kind of a client node, but it's also working remotely. So it can go just to a remote cluster and fetch data from that. And that is kind of, it's not really full multi-cluster support or anything, but this is kind of our workaround. And tribe nodes are just a remote or multi-cluster supported client node. Think of it like that. And then in the next version, there will be a new ingest node. This is taking over part of what Logstash is currently doing. So Logstash has these grok patterns, for example, to parse data. And that is what the ingest node can do as well. So it uses the same syntax for grok, just a regular expression, and it can parse your data as well. And because this is also a common question, ingest nodes will not replace Logstash. Logstash will still be around in the future. It's just kind of, if you have a very simple setup, ingest nodes can take that over, but for complex stuff or more or different things you want to connect, you will want to use Logstash still. Okay, and as somebody might have heard, like a month ago, we bought another company, which is in the space of machine learning. It's mainly for alerting. And I think the idea is to have another node type called pre-alert node, so that will learn like what is normal in your logs or your system metrics you have, and can then alert you what is not normal. But that's very sketchy. They were just acquired recently, and we will try to integrate that better into our products, but we might have new node types in the future as well. Okay, so now we have the different nodes. Now we kind of need to put them together. So the protocol to put everything together is the send discovery. We're not using any like proven or big implementations that anybody else wrote, but we have our own implementation. Some are critical of that, but there are some good reasons and probably some bad reasons for that. Part of the good reasons are, A, we can use the regular traffic for health statistics, and the other thing is all the other implementations do not cover exactly what we really need, both in terms of sharding the data and then replicating it. But it is an ongoing discussion. Should we use a tried and tested algorithm there, or should we use our own implementation? Even though the current implementation is pretty similar to proven algorithms already. So in general, you have a peer-to-peer network, and you have two things you need to be aware of. First off, you have an address, who do you contact? And the second element is a ping. You just ping the other nodes and see who is actually available and yeah, what is going on and what is my global cluster state. And based on that information, you have some nodes which are cluster eligible, and one of them will be voted the current master. And just one of them. If you have 0 of them, it's not good. If you have more than one, stuff is seriously broken and you will have trouble. So there should always be one. And normally you just start up one node. That single node becomes the master. And then all the other nodes that are added to the cluster will then join that master node. Once that master node goes away, or you have a network partition or whatever, a new node will be or will announce itself and then will be accepted by the others, and then that node will be the new master node. And like for production systems, the general advice or the setup we want people to run is to have, at least for bigger clusters, to have 3 dedicated master nodes, why 3, you always want to have an odd number so you can form an easy majority, and dedicated master nodes so that they are not burdened with any other stuff, and that normally keeps your cluster healthy and in a kind of stable position. So 3 dedicated master nodes are kind of what we suggest, or at least for bigger clusters. If you just have 3 nodes entirely, just use data nodes and master nodes in combination. Yeah. And the master then health checks all the other nodes, and they normally reply back. And then the master knows, okay, I can reach everybody, and everybody can reach me, and the cluster is in a good state. A few things you want to configure, or you might want to configure. The first thing is discovery send. So that is all. It's a discovery protocol. Send is the default implementation most of you are using probably. No master block is what happens if there is no master node at the moment. The default is write, and or you can set it to all. So in the default, only write operations will be rejected, but you can still read from the cluster state you have everywhere. Whereas if you set it to all, no operations at all will be possible if there is no master node available at the moment. And that is probably the most important setting. If you do not, or if you have more than one node, please set this, otherwise your life will be bad at some point. Discovery send minimum master nodes. This is the eligible master nodes divided by 2, floored plus 1. So you have a majority of the available nodes, so your cluster cannot divide and have a split brain situation. So if you have just 2 eligible master nodes, you can only vote a new master if both of the nodes are available and can see each other. Because 2 divided by 2 is 1, plus 1 is 2. Only if you have 3 nodes, then only 2 of the 3 nodes need to see each other to actually form a cluster. And always a majority, so you cannot have 2 clusters in case of a network partition. So please do that, otherwise you will end up in a split brain situation sooner or later. It's not guaranteed that it will happen like today, but it will happen at some point, and it will not be a good day for you. Like, there is no automated way to combine that data. So you have 2 masters, your data will diverge, and there is no automated way to recombine that data. Ideally you can read the data from some other source again and can re-index. Other than that, it's probably lost, or you need to do some manual stuff that's not fun. And you generally can get the cluster state, and the cluster state will be either green, yellow, or red. Green is if everything you want to have in your cluster is available. That will be your primary shards and your replicas, we'll get into that in a moment, are available and allocated and read and writable. Yellow will be your primary shards are available, but not the replication as you've set it up, which means you can read and write all the data, but you don't have the replication, kind of the safety factor. And red will be not all the data in your cluster is available. So ideally, your cluster is always green, and you check for that as well. Other discovery protocols you might want to use. If you're on the cloud providers, you probably don't want to have unicast or anything. You probably want to rely on their APIs to discover your other nodes. We have plugins for that. So Azure, AWS, and Google Compute Engine, all of them are supported. Okay, so let's get back to a single document. We did the curl command, or whatever we did in the beginning, and we want to index that document. And now let's see how does that work. When we say indexing, it probably doesn't mean what you expect it to mean. So index is kind of an overloaded term in Elasticsearch, because you have both an Elasticsearch index and you have a Lucene index as well. And to index basically means just store data in Elasticsearch, but it doesn't specify which one of those you mean. So you have the Elasticsearch index, which is the big thing, and every single shard of them is a Lucene index then. So by default, you have 5 shards per index, so you have actually 5 Lucene indices in the background. And you have, by default, a replication factor of 1. which means you will have in total, for one Elasticsearch index, you will have 10 Lucene indices on disk. And for Lucene itself, it is exactly the same if you have one Elasticsearch index with 5 shards and replication factor of 1, or if you have 10 indices with a single shard each and 0 replication. For Lucene, Lucene itself just sees its own Lucene index and doesn't know about the rest. That is what Elasticsearch takes care of. But Lucene just sees its own shard or index. Okay. So now we want to store a document there. What is one document, or how do you define one document? A document is always a unique combination of the index we provide, the type, and the ID. And all of these three actually define what one document is. And if you reuse the same for all three attributes and actually put a document against Elasticsearch, you will overwrite the existing document. So this combination is guaranteed to be unique. What is the difference between posting without providing an ID and putting? So for example, here I'm doing a put into the index database, and the type NoSQL, I'm inserting a document with the ID Elasticsearch, whereas at the top here, I'm posting against the index databases and the type NoSQL, but without providing the ID. Where do I get the ID? Elasticsearch will generate that for you, looking something like that. And it's basically 20 characters, URL safe, base64 encoded, and globally unique. So this is, I think, very, very secure, that there are no collisions with any other ID. There are some comparisons like, I don't know, if you generate a number 1,000 times a second, you could, I don't know, generate IDs for millions of years until you actually have a 50% chance of running into a collision. So this is very safe. This should not be an issue of having duplicate IDs. Okay, then we apply consistent hashing to actually hash our ID. And that will then define where we put our document in the cluster. Any ideas why I want to apply that consistent hashing and why I don't use the ID directly? But I could still use the ID of Redis or whatever I have. I mean, I'm in the case where I put my document with the string Elasticsearch, that would be the ID. Why am I not using that ID directly?
Probably your method of hashing may distribute data across shards and kind of balance.
Yeah, exactly. The point is I want to avoid any hotspots. Like if I provide my ID with a normal string, probably the document starting with E will get most hits, whereas Q and Z or whatever will get very few hits. So I run my hashing algorithm, and assuming I have a good hashing algorithm, it should distribute my data very evenly over my key space. And this is using DJB2. Any ideas who DJB is? DJB? DJ Bernstein? He's kind of a mathematician, and he has done lots of cool stuff. For example, he has written the original Demonize tool, and I think he has his own mail implementation, and he has lots of cool packages. But he was also very opinionated, and he says like his software is nearly perfect. He doesn't do updates, and like once he has written it, it's good forever. And I think the Demonize tools, the original ones I've used in my previous company, they haven't been updated in 10 years, but they're still like working perfectly. You could define custom routing, but we won't go into that. That's going too deep. But you could define your own routing algorithm, but that's not needed. This is what DJB2 actually looks like. Basically, you take a hash, multiply it by 33, and then add the next character to it. Why 33? I think this has never been explained, but it's kind of a magic key. You just using for the hashing algorithm. But that's all there is, and that should be really fast to hash. And then, now that I have my ID generated, I have hashed it. Where does it actually land? I calculate the hash modulo the number of primary shards I have, and that will define in which shard I put my document. So if I have 5 shards, I have my entire key space, I put it into 5 pieces, and then the result of that function will define in which shard I will put my document. Okay, so let's actually write something. So we have our client application again, and that client wants to write some data. And it goes to any random node. It doesn't need to know which one is the master or anything. It will just go to any Elasticsearch node in my cluster. So it writes to that node. The next thing is that node actually knows the key space, calculates the hash, and then knows, okay, this is the primary shard for this document. And it actually will send that document to the primary shard. Then the primary shard will know, okay, this is the replica shard for the whole thing, and writes the data to the replica shard. And then the replica, like, assume you could have way more nodes here. You could have 10 nodes, for example. These are the only 3 you actually need for that transaction. And then the replica shard tells the primary shard, okay, I've received the document, I've written it, it is applied. Then the primary shard can go back to whatever node got the initial request, and only that node then will tell the client, okay, I have actually successfully written down your document, and I'm now good to go. And how do you guarantee consistency? In relational databases, you normally have a very pessimistic approach. There you just lock stuff. So you say, I assume something will go wrong when I write this. So you actually actively block everybody else from touching the record you're changing. The NoSQL world is more optimistic. It's kind of the friendly smile assumes everything will go well. So here the approach is you have, every time you write a document, this includes deleting a document, the ID will increase. And then, if you want to use that feature, you can say, okay, I have read a record. It had, for example, the ID 5. And when I write this document back, it still needs to have the version 5. Otherwise, somebody else has written in between, and I'm potentially overwriting their data. So then you would get an exception, and your application will then need to handle that, but that is how optimistic version control works. So you have the underscore version, and you can use that to say, I will only overwrite that document if I have the right version of it. Otherwise, I will stay back and not touch it. And one other thing you can do is, if you have flaky nodes, Elasticsearch is very eager, just like once a node disappears, it will try to replicate whatever data was on that node again, so no data can get lost. But this can be a bit too aggressive sometimes. If your network is not that stable, you can actually tell it like, up to a minute, if one node is not reachable, don't do anything, don't try to push around the shards and reallocate them, and potentially do that in vain because the node will come back after or within half a minute again. You can actually say, okay, if it happened within a minute, wait for a minute and only then try to reallocate data. Okay, now this was all pretty high level. How does Lucene actually write the data? Like, this is one step below. How is the data actually written? So the Lucene network, this is kind of what we talked about yesterday, the full text search, indexing, stemming, stop words, etc. So you assume you already have everything analyzed and you have created your index, and you just want to write that data now. So the first thing is you have a buffer, and you write your document into the buffer. And you fill up the buffer, and you fill up the buffer some more, and then the buffer is full at some point. Then you write out a new segment. The segment is just an immutable form of the documents you have written. So it's just written into one Lucene segment. But that buffer is ephemeral. So the data, while I'm waiting to write that segment, could be lost. To avoid that, the data is not only written into a buffer, but also in a so-called translog. This is like a write-ahead log, WAL log, which will also take all the write operations. So you fill up your buffer and your translog in parallel. So you keep writing, you write out the segments, the translog still keeps up filling up. The translog keeps filling up more. More segments are written than the translog, or you hit the specific time barrier, and only then the segments are actually f-synced to disk, which is a quite expensive operation, and only then the data from the translog will be removed. And if anything happens in between and that data has not been f-synced to disk and your node crashes, your server restarts or whatever, the data has been written to the translog to disk, and you can still read it from the translog and just replay everything you have in your translog into segments, and then you can write them once the node comes up again. So this is how you guarantee that if your node dies, no data gets lost. And by default, I think the f-sync happens every 30 minutes or 512 megabytes or something like that. But the translog is by default written after each single operation. You could change that if you say speed is more important than data safety, but you will need to configure that explicitly. Okay, and then segments are immutable, which sounds kind of strange because this is a data store and I want to change my data. But you don't actually do that. What you will do is you have a so-called tombstone file, and there you define, okay, this document I've written once and I have updated or changed it. This is no longer active. Like, this is still in the immutable segment because you never change the segment. But the tombstone is kind of a file next to it and says like, yeah, but this document is outdated, ignore it. Like when you search it in the segment, all the references in the tombstone file will be simply filtered out and not returned in your searches. So this simply marks documents as deleted, and at some point later on, data keeps up piling up, and you have more and more segments. You will have an actual merge where all the old segments will be taken, only the still active documents which have not been deleted or overwritten will be kept, and they will be merged into a new segment. So it's like these files will not be lying around forever, but they will at some point be merged into a new segment file. But once the segment file has been generated, it is never touched or changed again. Okay, so we've written everything. Now we actually need to search it. So first thing, we have a coordinating node. And that coordinating node is coordinating your query, and this is actually a scatter-gather. So what this looks like, you have a query phase. In that query phase, your client will, for example, go to a client node and will then read data. For example, we have primary shard here and a replica shard here, and it will read the data either from a primary shard or a replica shard. That does not matter. In that example here, I'm reading from the primary shard for the data, or for the index 1, and from, okay, that was a bad example, from the primary shard with the index 0, but you could read it from the replica shard as well. So that is the first phase. The client node knows the query, sends the query to all the shards and tells it, give me all the documents you have for that query, sort them, and give me your 10 best results. Then it will give the 10 best results, but just the IDs and the score of the results back to the client node. And then the client node goes into the fetch phase. The fetch phase is, I know I want to get, I don't know, for example, 10 documents in total. So each segment, each shard has replied with its 10 best matches, and the coordinating node will then find the 10 best results overall. So each node must provide its 10 best results, maybe all the best results coming from a single node, so that each of them must provide that. And then in total, the best 10 results are actually selected. And then the client node will actually go to the shards again and tell the shards, give me back those specific IDs. Because until now, you have just received the ID and the score, but not the actual content of the document. And only in the fetching phase, you will fetch the actual documents, and only then will the client get back the data. So this is how the search then actually works internally. Okay, one other thing, snapshots. That is a nice attribute. You have these immutable segments, and they are written, which makes backing up easy. Because you just take a segment you have written, you copy it, and that also makes incremental snapshots super easy. Because you just know, okay, these are the segments I have already read, and just the new ones I still need to copy, and you have all the data you need. So immutable segments are super easy for that, and you can have easy incremental backup with that. So, what could go wrong? Unfortunately, lots of stuff. We have everything documented on our resiliency page. So this is your number one source. If you have any doubts about anything, go there and see what's happening. These are just some examples. This is not an exhaustive list, like it would be really long, but these are just like some high-profile examples. Lucene didn't have any checksums, so you would not know if data has been corrupted or not. And we saw that this is kind of a problem. We hired a few Lucene core committers, and they implemented it in Lucene. It was added in Lucene 4.8, and later on it has been added to Elasticsearch incrementally. I think we are at stage 3 now, so it has been rolled out to more and more features. For example, it has been added the snapshot, the checksums have then been added to snapshotting, so that these are actually checked. Or something that is really bad, split brains could occur even if you had set the minimum master nodes correctly, which could totally corrupt your data. We fixed that in version 1.4. Or mapping changes were not synchronous. So when you inserted new documents and the mapping was not the same on all the shards, bad stuff could happen. That was fixed in 2.0. Or we didn't wait for once a new master was decided on, only now in version 2, it actually waits for all the other nodes to join, or the master editable nodes to say, okay, you're actually the master, and actually join together and actually wait for that and avoid any problems in master selection process there. Or we didn't have two-phase commits for the cluster state. So the cluster state could potentially be in an inconsistent state. Or we could have loss of documents during network partitions. This is only fixed recently, like in the upcoming version. Or now, since we've tried to learn, we have so-called bootstrapping checks. Bootstrapping checks will apply if you have bound to not the localhost interface. We just assume if you're just binding to localhost, you're in development mode, so we don't care, you can do whatever you want. But if you bind to any non-localhost interface, we assume you're in production mode, and then we will run some checks. The first thing is you need to set the minimum master nodes. This is the first or the most common thing people will kill themselves, or their clusters at least, without setting that. Second thing is, did you set a heap size specifically? At least for production systems, you probably need to do that. You shouldn't use the Java serial collector because it's serial as its name implies, so it might be potentially slow in some situations, and there are situations where this node will just appear dead to the others just because the serializer is blocking it. File descriptors need to have a decent size, and threads, at least this is only checked on Linux, need to also be possible to create more than a specific number. These are just things people will do often wrong and have a very bad experience, and Elasticsearch will just not start up any longer if you're not binding it to localhost to avoid those problems. Good. What can still go wrong? Yeah, out of memory is still an issue, like with every Java project. Like, there are people who are more of the opinion that Java is just not the right choice for databases, and you shouldn't write it. We have tried to improve lots of stuff and try to not fall over that easily, but it's an ongoing effort, and there is a meta ticket where you can actually see what is going on. Yeah, repeated network partitions can cause cluster state updates to be lost. We've mostly fixed that, but there is some stuff that is very hard to catch and that will need more work in future versions. Another common cause is bad hardware. If you have a bad hard drive, really weird stuff can happen, and often if support says like, this looks like it's a bad hard drive, people running it don't believe it, and after some time it turns out, well, actually the hard drive was really bad and that was the cause for issues. And kind of the worst thing is users. Like, users will always do stuff wrong. And there is one very nice thing. I've explicitly blanked out the person not to shame anybody, but at one point we saw the tweet, somebody was woken up at night and wrote some thing to actually force shard allocation in Elasticsearch. And when we read it, we said like, this is odd, this shouldn't be done. And the person was not really reactive to it, so Shai, our CTO, personally reached out and said like, hey, can we help you? Something funny is happening. And then the person like asked, do you have a Jira project? And we were like, no, we're on GitHub. That is a really weird question. Who would want to have a Jira? But yeah, we just took that as a little personal insult. And like there was a little back and forth, and in the end it kind of turned out she had set some pretty arcane setting where she had explicitly disabled shard allocation, and then she wrote her own Python script just to force shard allocation again. So yeah, often users will do bad stuff and it will look like stuff is totally broken, but there's no easy way around to fix it. Common questions, just to avoid your questions later on. When will version 5.0 be released? Obviously I cannot say, because we don't know, but it will be soon. We're at release candidate 1, so yeah, definitely this year, hopefully really pretty soon. Can I use Elasticsearch as my primary data store? Our answer is always like, it depends, and the real question is, should I use Elasticsearch as my primary data store? And again, it will totally depend. Like, we're very confident to say, if you're just storing log files, for example, yeah, why not? Probably speed is more important and kind of ease of use than losing a few log messages. If you have banking transactions, we're a bit more cautious. And the official line on the resiliency page is still, ideally you have another source where you can re-index your data from, then it does not really matter. So we're trying to be a bit cautious here. What about cross-data center replication? That is one of the big missing features, and we're not sure it will be in the next version, but we're at least trying to get the groundwork started. So we need serial IDs to actually be able to replicate over remote connections. So we will see how that goes. Favorite question is, don't containers solve all my problems? Yeah and no. We're always like, for stateless stuff, containers are great and they will solve your problems. But probably not really for stateful stuff. But we do provide official containers now. So if you are looking for Docker containers for Elasticsearch and Kibana, we've written a blog post. We're running our own registry at the moment. So it's not on the Docker registry, but we're referencing here ours. Currently is only available for the release candidate of 5.0, but as soon as 5.0 is out, there will be stable containers for Elasticsearch, Kibana, and we're currently working on Logstash, so I hope that will be available soon as well. Good, to conclude. Meaning of index, don't be confused, it can be an Elasticsearch index and a Lucene index, that is one common source of confusion. Storing a document, we've seen like how to get the ID, how to hash the ID, which means to which shard it goes, and then the shard writes it, and you have a translog. So you see all of these steps you need. How you can search a document, you always have this coordinating node, so your client goes to the coordinating node. The coordinating node will then gather all the shard results, aggregate them, fetch the actual results it needs by ID, and give you back those IDs. So this is what a search really quickly looks like. Yeah. Then there are the documents on resiliency. If you have any resiliency doubts, this is your #1 source. And we have all the GitHub issues and everything else linked there. So if you have any questions, this is where you should get started. Other than that, any questions, which I have not answered yet?
If you have like some tombstone segments, and but you still need that data, can you force like using some setting to search through that data? Because the merge has not happened yet, and you still need that data.
Yeah.
But that data has been tombstone already. So can we search through tombstone segments?
You mean like retrieving old versions of files?
Yes.
No. That's not a feature that is provided. We don't provide like previous versions or stuff like that. No, there is no easy way to do that.
One question about architecture. You mentioned that Elasticsearch has master nodes. What advantages of using master node concept for Elasticsearch? Why not go like Cassandra with masterless?
Because we have the global cluster state, and that is just like the master node takes care of that. So that's why we have the master eligible nodes. Also, Cassandra uses a very different approach. In Cassandra, all the nodes are the same, whereas in Elasticsearch, we have the different node types. So this is just, we're using a different approach. You mean, why do we even need master nodes? Because we have stuff like you can just hash the ID and then you could just spread the key space. Well, we also have stuff like which indexes even exist. So it's not that easy. Also, our data schema is a bit more elaborate than what Cassandra provides. And to do that easily, we need to have that global cluster state. So we need master nodes. Yeah, back there.
Thank you for your speech. I have some technical question. When we are writing a segment, is it written through a time slice for different document, or it is serial?
Well, you fill up the buffer, and at some point the buffer is then written out to a segment. I think that is the refresh rate you will want to set whenever you write that out.
I mean, a single document is written to the buffer, well, serially, or different documents are written at the same time through some time slice.
Documents are written to the buffer, and once the buffer is either full or you run into a specific timeout, the buffer will be segment will be created and written out. And that segment will then be what you want to, for example, search in, or that is why Elasticsearch is not real time, but we always say near real time. We have this so-called refresh rate. Like, by default, it's 1 second, but depending on your use case, you can either disable that or set it higher. How soon the data will be available, because then you package it up, write it out as a segment, and only then will it be available for full text search. But for example, getting by ID is available immediately, because you do not need the segment for that. Any more questions? No. I have some more swag there. The little white things are so-called phone wallets. You can stick them to the back of your phone, just because everybody's always asking, like, what is it? Those are phone wallets, and I have my stickers from yesterday and everything. So yeah, grab swag and come to me if you have any more questions. Thank you.